All right, this is the follow-up video to my first one that I made on the overview of the H-120 Ash Army Space Heater. A couple of the modifications that I did to it, and I actually got it hooked up to the house today because it's for South Texas, it's a really cold day. I think it's 40 degrees and it's like rainy and stuff. But anyway, the first change I did to it was I made it so it has the same auxiliary fuel hookup as the tactical quiet generators, like the MEP 802, 803, all that stuff. So it didn't have that proprietary connector there. Cleaned up this a little bit so you could kind of see what the fuel level is in there. The other thing is found the part with thanks to some of the guys in the Steel Soldiers group for this. It's not a direct fit. I had to get an adapter. The NSN was replaced. So from what I showed in the first video, it doesn't show 100 PSI on the gauge when you have it in vent. So I'm going to kind of go over the startup again. When you move it to vent, you'll see it comes up to like maybe 30-ish. And then when you hold the purge switch, you'll see it drop just a little bit. And if there's air in the lines, you'll see the gauge go up and down a little bit. And then when you move it to heat auto, you should see that black puff of smoke come out. So it's starting up, and then your gauge shows the 100 PSI, give or take, depending on the temperature. So we'll let that run. It's running. Here I am not following my own instructions. That's supposed to come off. So I have this set up right now as a fresh air intake going into the house. I did this as kind of a proof concept to see how well it would work. I just made an adapter to go into a window similar to like a window air conditioner unit and just have the heat blowing going in and then run the remote thermostat in there. You can see I put it on heat auto, and then I got it plugged into the wall outlet with the adapter I made, and it's just pulling in fresh air. Ideally, what you want to do is you ought to want to have maybe a second adapter to a window, preferably farther away so it's kind of circulating heat throughout the house. But in order to see how it worked, I wanted to just hook it up like this. These old insulated collapsible vents, big pain in the butt to get on. My wife, who's recording, we were out here fighting for about 30 minutes to get this one on. Part of the reason why I didn't make this whole setup right now. But did find that there are non-insulated versions in much different lengths available for like confined space entry blower fans. And they come where they collapse like into bags and stuff like that, and they're available on Amazon along with the adapters and stuff like this. So I'm going to have links in the description to stuff like that so you can take a look if you got one of these and you wanted to make some vents and stuff for your own. I may end up purchasing some of those myself, but I'm just trying to make this stuff work for now. So kind of just take a look at what I got set up. It is running right now. So I'll take you in the house now and show you what it looks like in there. All right, so we're inside. I have it set to 70 degrees right now. And I've already actually had it running for quite a bit. And it's working very well. It's getting it hot in here. One thing I will say that when I set this up, not that I'm leaving it in here permanently, but as this permanent window adapter, I got to put some sort of diffuser because it's blowing everything everywhere, which is a good thing for circulating it, but it's a bad thing. Like we had a whole bunch of papers and stuff on the other side of the office and everything in the bedroom, and it just blew stuff all over the place. Kids think it's funny. Anyway, but with it set up as fresh air, the one thing I noticed as the thermostat is kicking on and off, but it's not doing that great of a job of regulating the temperature in here. The reason being is without it actually circulating air, is it's pulling in cold air from the outside, which is cooling off the thermostat, which is on the discharge side, which I showed and we took that temperature reading at in the first video. It doesn't actually take the reading at this. This is just to change your reading. But so this little metal piece that I have going into the piece of plywood here, this is just a piece that's used like when you're making your vents in the housing. Again, they're available like all over the place, but I'll put a link in the description to that too. It's all 12-inch stuff that comes out. And you know, you can neaten up for the wires, but I just got the wire run kind of up in between, and that's holding everything in here. It's very secure in the window, but making something out of the plywood for yourself, I can't really give you guidance on that because you're gonna have a much different window. I've had this thing only running for, say, about a half hour into the house. It started at 68 degrees in here. I shut it off for about 5 minutes before we started the video, and let's go see what the thermostat in the house says. So it's showing that it's 76 degrees in here, and what I did is I shut the HVAC off and just put like the circulating fan on so it would pull air over here and send it out. And it just keeps going up. Like I said, that's set at 70. It's not regulating the temperature that well because it's just pulling cold air in from the outside, so it's not actually getting any sort of reading from in here to know where it actually needs to shut off at. But you would just need to figure out where that temperature is at from a fresh air reading if you wanted to without putting circulated air back into the unit. All right, so one last thing I wanted to do before wrapping up this video is kind of show you how much power that this thing uses up. I got it set on wattage, and this is just regular 110 volt plugged in. So I'm going to move it to vent first, do the purge switch, and then I'm going to move it to heat manual, which is going to pull the most energy. So you can kind of watch. So it's about 1,000 watts there. Purge. Doesn't really seem to make much of a difference. And then looks like it peaked at about 1,500 watts and then it settles back out at a little over 1,000. And then let's see where it goes to heat auto, if it makes any difference, unless it shuts off. Nope. So I'm sure there's a little bit more of a surge that this thing isn't picking up on. Just to give you an idea, so if you were running this thing out in the field and you needed to say you had like an off-grid system or a solar, again, if you have any other questions on this unit, let me know. Links in the description to any of the stuff, and hope you found this informative.